So when we have a relationship between X and Y, usually we use the letters X and Y, we think of the numbers that we plug in as the X's and we call those the domain. And whenever we plug in that X and the answer that comes out, that is our usually our Y value. So those answers that we come out, if we collect all of them together, we call that the range. So when we are looking at a function or a relation, we often think of the domain as the X values that we are plugging in and the range as the Y values that end up coming out as answers. Now, we need to be able to, given any map, any set of ordered pairs, any graph, and any equation, we need to be able to identify both the domain and the range. So we're going to start with an ordered pair. Remember, domain is the x's we plug in, range is the y's that we come out. So with ordered pairs, the domain is very finite and it's just like a set of numbers. So what is the domain that we are plugging in to this set of x's and y's? Well, the domain from this first one is a 1, and then we have an x of 3, we have an x of 5, we have an x of -1, and we have an x of -2, and that is the domain. If you ever repeat x's, you're going to only list them once. What is the range of this set of ordered pairs? So what are all the y values that are coming out as answers? Well, those are 2, 4, 6, -3, and 0. Notice that the order doesn't matter, but again, only list things once. Okay, let's look at this mapping. What are the x values that we are plugging in? Well, those are these numbers, probably salaries or probably net worths. And then what are the y values that are coming out? That is our range, and that is the names of people who are in show business. So if we look at this, the domain is the 3, 15, 80, 55, and 51, and the range is all of the names of the people in show business. That is our basic understanding of domain and range. Now, it does get a little bit trickier when we start looking at graphs and determining what is the domain and the range for a graph. So remember, domain is x's, range is y's. But when we're looking at a graph, we also want to remember we're going to have to list infinitely many points, because if you look at all of the x values, say on this circle, there are infinitely many dots because this is a solid line that goes all the way from one place to another. So there's infinitely many things. We can't just list them like we did with the previous problems. We're going to have to use interval notation to answer the domain and range on these. So the easiest thing we need to do is to remember to get our interval notation correct is to think in a graph, domain is x values from left to right, and that the range is y values from bottom to top. Okay, why do we always want to think left to right and bottom to top? I know you want to think top to bottom, but it's bottom to top. Why? Because we always, when we're using interval notation, we always want to put the numbers in numerical order. So this would be allowed. -2 is first, 4 is second. That is number line order. But if we wrote it like this, that is not allowed. That is not proper interval notation. So that's why we always want to think, what are the x's from left to right? What are the y's from bottom to top, not top to bottom? So let's write our domain and our range here. So what we're going to do is we're going to take your pencil and think vertical lines. And what is the first time that we have a graph of a line, that we hit that graph? What is the x value at this very first place that we hit the graph from the left? Well, that x is a -4. And then you can see we have solid line graph until we get to what is the last place from left to right where we have an x value on our graph. Well, here that x value is 2. So what is the domain of this graph? It is -4 to 2. And since there is a solid line here and there is a solid line here, we will go ahead and include the -4 and the 2 in our interval notation. Now, what about the y values? From y values, we think bottom to top. So think of this line as coming up and up and up. And does it first hit graph? And what is the y value where we first hit graph? Well, this y value right here is -2. And then we have y values for all of these points until we get to the tippy top of this graph. And what is this y value way up here? It is 4. So our range starts at a small y value of -2, ends at a large y value of 4, and since they are solid lines, we will include both of those. All right, so let's think of it again. What is the domain and range on this next one? Okay, domain is x values from left to right. So we're going to start over here on the left and ask, okay, what is the first dot that we get on the very left-hand side? Well, the first dot happens here. And what is the x value on this dot? Well, that happens at an x of -4. Then we have graph, 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 graph. And okay, does anybody know, what does this arrow mean? It means it goes up and out at the same time. So it's going to go up and out forever. So what is the last x that we get to if we have to go all the way that way? What do we call that last x value? It's infinity. So we're going to start at -4. We're going to end at infinity. Remember, infinities are never included. We always use a parenthesis. This is a dot right here, so we will include the -4. All right, what are the y values? What is the range? So we're going to start at the bottom and we're going to come up. So take this line and think, bring it up. What's the first time that it hits the graph? That is right there at that dot. What is the y value at this dot? The y value at this dot is -3. So we're going to start at a -3. And again, because, okay, I know that on this side we stop at 1, but on this side we go forever. So you pick the one that keeps going, right? So this is going to go up and forever on the right to positive infinity. Again, not ever including infinity or negative infinity. But since this is a solid line here, we will include the -3. One last little thing. If you ever have a picture like this last one where there's no arrows, but you see how the line here just kind of runs off the graph paper, you're going to see this on computers a lot. When that happens, think, oh, this goes forever and it keeps the pattern, right? So just imagine arrows there. So if we think about it that way, if this thing goes forever to the left, what is the x value that's all the way down there to the left? Well, that's -infinity. And if it goes forever to the right, what is the x value that is all the way to the right? Well, that's infinity. So our domain on this one's a little boring. It's -infinity to infinity. The range is a little bit more exciting though. So take this line down here and bring it up. What is the first time we touch graph? It's right there. And that is a y value of 0. It is a solid line, so we'll give it a square bracket. And then, okay, this side we go up and we stop at a y value of 3. But notice this one goes higher and goes up and stops at a y value of 6, and it's flat at 6. So we're going to pick the bigger one, and we're going to go all the way from 0 to 6 as the range. All right, now there's one other little issue that people come up with, and they see bends and holes, and they kind of go, oh, what is going on with these bends and these holes, and how does this affect things? So if you look at this set of graphs right here, this bend right here, is the bend mean that we stopped the graph right there? Did we stop the graph here? No, we didn't. There is still picture there, right? So even though the graph kind of changes directions, the x values don't stop. So the first x value happens here at -2. It ends here at 1. So this graph would have a domain of -2 to +1. This is our domain. Now, what would be if we had exactly the same graph, but instead we had a little hole right there? Is that now part of the domain if there's a hole? Well, now if there's a hole at that spot, that means that there's no y value happening right here if there's a little circle hole. So we have x's from -2 to 0. Remember, we're thinking x's from -2 to 0, but there's nothing at 0. But then there are x's from 0 to 1. So how do you write that? Well, think of it as in two chunks. We've got the -2 to 0 chunk. There's nothing at 0, so we don't include it. And we've got the 0 to 1 chunk. Again, there's nothing at 0, so we don't include it. And you can kind of see how this looks like. They took 0, -2 to 1, and then we just cut the number 0 out of it, right? So just be careful with bends versus holes. A bend, it's still going. But if there's a hole there, that is not part of it anymore. And we can kind of see what's going on in those.